Hello friends, how are you doing? So I am Dr. Suresh from Infosys Limited. I work out of Global Education Center at Mysore. Today and for next 2 to 3 hours, I will be discussing one of the strongest feature of C programming language, which are pointers. So within the scope of pointers, these are the topics which we will together learn. So pointers and addresses, pointer and function arguments, pointers and arrays, the arithmetic of addresses, character pointer and functions, pointers to pointer, initialization of pointers arrays, and dynamic allocation methods. So before we actually get into the nitty-gritties of the C syntax of using pointers, let us look at the fundamental reason why pointers was made available in programming language C. I think in the initial classes in this course you must have studied the von Neumann architecture, where you had the 5 components of the modern day computer, in which storage or main memory was considered to be one of the vital part of the von Neumann architecture. That is the storage, or that is the place where your program, that means the instructions and the data, would reside. So the other name given to the von Neumann architecture is also stored program computer. Okay. So to keep things simple, memory can be conceptualized as a linear set of data locations. If you see the picture on the right hand side, you see an array of boxes. Each one of them is basically a memory location, and in all computers, including the modern day computers, 8 bits can be stored in a single address. So it's a linear set of data locations, and conceptually you can say that the memory location starts from a smaller address, let's call it as address 1, and then it's a linear order and go to a higher address of say address n. In reality, addresses are nothing but numbers. So they are basically a fixed range of contiguous integers. So for example, on the right hand side, you must be watching now, the addresses have now been replaced by 1, 2, 3, 4. So typically the address starts from 0, so I have marked it as 1 to keep things simple. So 0 to 1, 0, 2, 3, because the highest address typically in most of the practical machines is a power of 2. So 2 to the power of 10 is 1024, which we generally called as 1 kilobytes. That is a block of storages that you see on the right hand side. So the numbers 1, 2, 3 and so on up to the highest address are what we call as addresses. So now we have programming languages, and we code or we program the computers using higher level languages. You have already gone through sufficient say depth in programming language C. So if you see on the left hand side, we have a small piece of code, integer sum is equal to 0, character gender equals to m, int fee is equal to 1. So that is what you write in a typical higher level language program. In this case we are using C. So if you look at how it actually boils down, or how it actually gets transferred to the main memory. So when it gets transferred to the main memory, you have names, which is sum, gender, fee in the piece of code that we have seen. These are we generally called as the user's view or the programmer's view. Programmers see sum as a variable name, gender as a variable name, fee as a variable name. So when the compiler compiles and then requests the operating system to load the program, this is how it looks. So address 0, you have the compiler allocates an address 0 and requests the operating system to give address 0, and sum is being kind of associated with location 0. So address 0 and sum are primarily the same. And if you see on the last box, the rightmost box, you see the contents. So what you want to store in the storage. If you see the first statement is sum is equal to 0, and that's exactly what you see in the box there. So here we have assumed that we require 2 bytes for an integer. Okay, so it is machine dependent. In some machines it is 2 bytes, in some machine it could be 4 bytes. So subsequent to that we have gender, which has an address associated to 3, and then the contents is M. So I have shown it as M, but primarily what you will see is a binary representation of ASCII equivalent of M being stored in the contents. So the last one phi, which is similar to sum, but the only thing is you have a number stored there. So there's a slight mismatch with the value phi is equal to 1 and what is stored in the contents. I think that's an error. Basically the contents that is stored now currently is about 32,000 something. So 2 to the power of 31, sorry, 2 to the power of 15 minus 1 is the value that you see there. So it should be clear that the programmer space is basically the namespace, the machine or the addresses are the address space, and what we have inside the memory are basically the contents. If you know the distinction of the variable name, the addresses and the contents, understanding the concept of pointers and how to use the pointers, which will become more clear. Let's continue again. Let's see how a program maps on to the addresses and contents. So suppose if I say integer a, what compiler does is it gives some number of bytes. In this case we have shown it as 2 bytes, associates an address to it. In this case we have associated 1000 to it, and then remembers somewhere in its storage that a is referring to memory location 1000. And then when you say a is equal to 25, this is how typically we assign or we initialize the variables. What actually happens is that 25 goes and sits into that memory location. So the 25 would be basically a binary equivalent of 25. So now watch this. So you all have used this. If I say printf with a %d format and a, the output would be 25. So you all know this. Let's now do some minor tweak. You have the same statement. Instead of %d you have %u, which is basically to print an unsigned number, and I put an ampersand sign prefixing the variable name a. So if you go, I think you cannot guess because you are not been taught what does this ampersand do. So what you basically get is 1000. If you see the picture above, what is 1000? 1000 is basically the address of the memory location which is being referred by a, whose contents currently is 25. But here that ampersand sign in C would provide you the address of variable name a. Okay. So let's see one more trick. So prefix a star symbol in front of the ampersand a. So the star symbol, what it does is it gives the contents of the address specified following it. So and a is the address of a, which is 1000. Star will actually dereference it, and the contents of 1000 is printed, which is 25. So this I am giving you a kind of early introduction to what are addresses, how do you get an address of a variable name. Once you know the address, how do you get the contents of the memory location. Now when you reassign a equals 1000, can you guess what would be the change? So the change would be actually the contents of the memory location. So the 1000, which is now the contents of memory location, is very different from the 1000 that you see on the right hand side, which is the address of the memory location. In essence, you can change the contents of memory location, you cannot change the addresses themselves. So addresses themselves are very tightly bound. Basically they refer to the hardware. Okay, so you cannot change the addresses, you can change only the contents of the addresses. So that should be very clear. Now let's look at the definitions of pointers. We have already seen addresses and variable names. So basically pointer is a memory location which contains a memory address as their values. Just like variable names contains the values that you give, A pointer is a special type of variable name which can store only memory addresses. The normal variables that you know of, in the previous example a happens to be the normal variable, contains a specific value. So, and you know how to access it. If I say simply write an a, basically what I get is the contents of a. So, that we call it as direct reference. Okay. So, you know you say, I mean you access it as a, and the rest of the job is done by the compiler to see that wherever you refer a, you get the contents of a. Okay. Whereas a pointer contains the address of a variable that has a specific value in it. So, now if I have a pointer which stores the address of say a, if I use pointer variable to access the contents, so there will be two references that are required. So, if I refer to the pointer variable, I will get an address. So, that is one memory access, and once I get the address, I have to go and fetch the contents of that address. So, that is a second reference. That is why we call accessing memory location using pointers as indirect reference. Let us now get into the syntax. A star symbol is used with pointer variables. If I have to declare a pointer variable, invariably I have to prefix a star in front of the variable name that I want to be a pointer variable. For example, I have specified int my pointer, star my pointer. Okay. Basically, what you are instructing to the compiler using this syntax is defining a pointer which points to an integer, pointer of type int star. If I have to declare multiple pointers, each variable names have to be prefixed by a star. So, if I want to declare two variables, two pointer variables, my pointer 1 and my pointer 2, you see I need to put a prefix of star here, I need to put a prefix of star here as well. So, you can declare multiple pointer variables referring to the same data type. Okay. So, all these pointers now will refer to an integer, or will be holding an address which will contain an integer value. This is very important in C. Okay. So, you can define pointers to any data type. You can define pointers to any data type. So, for example, if I say float star my pointer 1, basically it declares my pointer 1 as a variable name which now points to a floating point number. Okay, that is very important. If you can make a pointer variable to point to a user defined variable. For example, structures or structs you have seen in some of the previous classes. Suppose you have defined employee record, which is a user defined data type now. So, you can associate a pointer to a user defined records as well. There is one special case in pointers which we call it as a void pointer. A void pointer is a special type which does not associate with any data type. So, you may wonder why you need this. So, in time, probably next 2-3 hours at some place we will visit this and see why a void pointer is required. So, void pointer variable basically is an address pointing to something which we do not know, the data type of which we do not know. So, now you may be wondering, so why should pointer be associated with a data type? If you remember the first slide, when I wanted to print the contents of a variable, a pointer variable, I prefixed it with a star. If you remember, we did printf %d star ampersand a, that we call it as indirect reference. Okay. So, if you see, actually in the memory we discussed integer may take 2 bytes or may take 4 bytes. Floating point typically takes about 8 bytes. Okay. So, for example, the user defined data type that you have employee record may take about 100 bytes. Okay. So, when you there is no fun in only having an address. There will be a mechanism, there should be a mechanism where you would use that pointer variable to access the contents inside that address or inside that memory location, that we call it as indirect reference. So, when the machine wants to access that memory location and interpret, it needs to know what is that data type, because there is a different format that we use for integers. We use a different format for unsigned integer, a different format for signed integer, different format for floating point numbers, different format for double. So, every data type have a different kind of representation. So, if you do not associate a pointer variable with a data type, dereferencing it would be impossible. That is exactly why we say that every pointer variable has to be associated with a data type. There is a special pointer called as void pointer, which basically does not know what it is pointing to. Okay. I hope you are clear in the syntax and the understanding of how to define pointers. Now, let us see what are the fundamental operators on pointers. So, just like arithmetic allows you to do addition, a subtraction, a multiplication, a division and so on, pointers also allows you to do some operations. But two operators are very fundamental to pointers. The remaining operations we will see it later. Okay. So, the first operator is basically the ampersand. So, the ampersand basically returns the address of the operand. Okay. So, for example, you see this bit of code. I have integer y is equal to 5, integer star y pointer basically defines a variable name called y pointer pointing to an integer data type. Now, I assign y pointer is equal to ampersand y. So, you see the usage of ampersand y. Sorry, you see the usage of ampersand y. So, basically as we discussed, the ampersand y returns the address of the operand. The operand to AND here is y. So, y has an address associated to it. So, the AND operator helps the programmer to get the address of the y. Okay. So, what gets assigned to y pointer is now basically an address, and that is exactly what we defined. We defined y pointer to hold an address of an integer. Y is an integer, AND is an operator, it is a unary operator. So, y is the operand to AND. So, you got the address of y as assigned to y pointer. So, if you see, when I said int y is equal to 5, that is exactly what the machine did. So, it remembered that y is a variable name and the user has assigned 5 to it, and inside the physical memory you have 5 in the memory location, and that 77 lakh or whatever the number that you see is basically the address of the memory location referring y. So, after the declaration, so y pointer, when you say integer star y pointer, that is exactly what the machine does. You have a y pointer which is a storage, okay, and what is that storage we do not know, because we have not yet assigned. And then what is that 50,000 is the address of the memory location of y pointer. Okay, please be very clear, 7 lakh is the address of y, 50,000 is the address of y pointer. In the third statement, when we said y pointer is equal to ampersand y, so now guess what should happen. Ampersand y is an operation on variable name y, and what is the operator? And what does that operator do? It returns the address of the operand. So, y has an address of 7 lakh, and that is exactly what it does. When you say y pointer is equal to ampersand y, so the contents of y pointer, which was earlier empty or unknown, now has a clear value of 7 lakh, which is the address of variable name y. Now, let us look at the second operator or second fundamental operator, which is a star. So, star is basically a dereferencing operator. So, we all know that we all now know that pointers are variable names holding the address of a particular data type. Star is an operator which we use on pointer variables. Pointer variable becomes the operand for star. So what it does, it basically dereferences the pointer. That means it gets the contents of the address held inside the variable name or inside the pointer variable. Let's look at it. I have star y pointer. I mean, if you see the previous code, we had integer star y pointer. So now if I say star y pointer, I will get 5. Star y pointer contains 5 lakh. 5 lakh happens to be the address of y, and star y pointer is pointing to 7 lakhs. So it will fetch the 5, which is the content of y. So star can be used for assignment also. Okay. If I say star y pointer is equal to 7, what happens? The address which is stored in y pointer, which is 7 lakh, will be overwritten. The contents of the address will be overwritten by 7. In effect, we are overwriting y. This is exactly why pointers are considered to be tough, considered to be complex. So at this point of time, when you say star y pointer is equal to 7, I do not have the picture of y at all. Okay, but if I see the previous lines of code, y pointer happens to be pointing to y. So we said y pointer is equal to ampersand y. Okay. Now basically you are using y pointer, which is a variable name, but the effect is happening to the location y. This sometimes, if not used carefully, can become very hard for the programmer to locate what is happening in the program. So that is why people say pointers are complex. Fundamentally the concept of pointers is very simple, but because of this power of indirection or power of indirect access, pointers sometimes, if not used carefully, can create huge or very difficult complexities to the programmer. So one more caveat here. The dereference pointer, that is the operand of star, must be a left hand value. So if you see in C, the left hand side should always be a variable name. Okay. So what basically it means, the star operator cannot be used on constant, neither it can be used on void pointers. If you remember, when we discussed the pointers, we said every pointer should be associated with a data type, and void is a special pointer or a special data type, special pointer type, which points to nothing, or which does not know where it is pointing to, but it still holds an address. So you cannot, if I put a star, neither the compiler nor the machine would come to know what it should interpret. It knows the address, but it does not know what is the data that is present. All it sees is some ones and zeros. It will not come to know how to interpret that data. So when you use star, you cannot say star 7, because 7 is a constant. Okay. So the operand to the star operator should always be an L value. So let us now sum it up, how to declare and use pointers by using a very simple example. So to declare a data variable, you know int a equals 10 is suffice. So what happens inside the memory? You get a memory location, you get a storage associated with it, and depending on the machine on which you are running, you will get few bytes to integer. Here we have shown it as 2 bytes. Okay. And what happens? 10 gets into that memory location. If I want to declare a pointer variable, so that is the way we do. Int data type and then star p. Star is the way in which you define pointers, followed by a variable name. So p is the pointer, okay, of p is a variable name of pointer pointing to integer. So what happens inside the memory? You get a memory location, in this case it is 1002, okay, and p is associated with it. Because you are not assigned anything to p, you have a blank space there. Okay. So how do you initialize a pointer? You already seen. So p is equal to ampersand a. Okay. So what is the ampersand operator? It returns the address of the operand. A is the operand, which happens to be an integer. Ampersand a is basically 1000, which is the memory location here. So what happens? The p, the 1002 memory location, the location here gets a value 1000. Okay. So, the addresses are basically unsigned integers. If I say printf %u p, p happens to be the pointer, what you get is 1000. So, address data using a pointer variable. Now, if I say printf, what is p? P is a pointer. Okay. Now, if I put a star, what is the star operator? It dereferences the pointer. P happens to store 1000, and 1000, the contents of 1000, memory location 1000 happens to be 10, and the expected answer here is 10. Okay. So, you are referring P, but what you are getting is the value stored in A, but please remember that we have assigned P to point to the address of A. Okay. So, you get 10 there. Let us look at one more example. So, all these things we have done in the previous example as well. So, that is what you get. So, this is just a recap of what we did in the example. Now, let us do some of the things that most of you would try to do when you write long programs. So, can we say reduce the syntax or do multiple things in one single line. So, this is what we saw in the previous example. So, I can move this into this. If you see here, we declared p to be an integer, pointer to an integer, and then we assign p is equal to ampersand a happens to be variable name which is already defined and also assigned. So, I can combine these two statements and make it in that fashion. So, integer star p is equal to and a. So, this is perfectly accepted by the C compiler. So, this is what happens on the inside the machine. So, because both p and a is associated with data type integer, I can combine declaring variables which are normal variables as well as pointers in a single line. Int a is equal to 10, which declares an integer a as well as assigns it to 10. Similarly, star p declares an pointer to an integer and also gets an assignment of address of a, which is ampersand a. So, both are fine. Those three lines of code is now compressed into a single line. The codes are equivalent. Now, let us see how do you initialize. How do you initialize the pointers? We have seen some, but we will see some more examples. So, if you see the first line, we have declared three variable names. One of them happens to be the normal variable name. The other two happens to be the pointers. So, IP and IP1 happens to be two pointers, two independent pointers. Both of them are pointing to an integer. Then you have float D and F. So, there are two variable names which are floating point numbers. Okay. Now, there are three lines here. So, let us see which of them are valid, which of them are invalid. IP is equal to P. So, what is IP? It is a pointer. What is P? A normal variable. So, what is IP? A pointer. It is always supposed to store an address. So, if I say IP is equal to P, so P is a simple variable. Okay. So, that happens to be an error. A pointer variable cannot be initialized with a simple variable. It has to be initialized always with an address. Then IP is equal to ampersand D. What is IP? It is a pointer to a floating point, it is a pointer to an integer. What is D? It is a floating point variable name. So, you cannot make an integer pointer point to a floating point number. So, the second one also leads to an error. The third one, IP is equal to ampersand P. So, IP happens to be the integer pointer, P happens to be the integer variable, ampersand happens to be the address of operator. This looks a well constructed C statement. So, this is absolutely okay. So, IP1 is equal to ampersand P is also okay. Okay. But here we have done a trick, or we have slightly complicated things. So now I have two pointers, IP and IP1, both are integer pointers, and both I have assigned it to point or to hold the address of P. So what have we done? We have two pointers IP and IP1, now both points to the same address location. So the same address. So there are many occasions where programmers use this power to do multiple things, but as I cautioned previously, now whenever I say star IP1, I will be modifying the contents of variable name P. But now because two pointers are pointing to the same location, if I say star IP1 is equal to 10, so P is getting modified to 10, but please remember star IP is also modified to 10. So that is the thing where pointers leads to complexities, but the same power can be used to write very efficient programs. Now having known how to declare variable names, how to declare a pointer variable, how to declare a pointer variable to different data types, how to assign the pointer variables, and also how to dereference the pointer, let us try to write some simple programs to show how pointers can be used effectively. Okay. Addition of two numbers. I have taken this example, though it is a simple example, just to demonstrate the usage of pointers. So integer a is equal to 10. So I will try to use this mapping of programs to the memory for most of my initial examples, okay, and later on until that gets etched into your minds, that if I say integer a is equal to 10, I get a box, I can store an integer into it, and I have an associated address to it given by the compiler and the operating system, and I can put an integer into that box that I get. So that picture has to, or that concept has to very clearly etch into your mind. So the more you practice with this, the clarity will be more clear. Okay. So if I say int a is equal to 10, that's what happens. I get an address, I get a box, and I also know that a and 1000 happens to be referring to the same memory location, and here I have already assigned it to 10. B is equal to 20, something similar happens, fairly simple, and then I have sum. What happens? I get this, I get that, I get this, but remember I have not assigned anything to sum. So inside that there will be nothing. So most compilers will try to initialize it to 0, but you should not assume that. That is why we say whenever you declare a variable name, see that it is initialized as well. Okay. Without initializing, if you access this, C does not guarantee what is inside it. It says unknown value. Okay. But it will print, if you access sum, it will print whatever is there, but it may be a junk. So then integer star PA, we all now know PA is the pointer variable pointing to an integer. What happens? In the memory, I get a box, I get a memory address to it, and a name associated to it. Star PB, something similar happens, I get that. So both PA and PB are not assigned. So now what I will do? So now you should be familiar. PA is equal to ampersand A, ampersand is the address of operator, A is a variable name or should be a variable name. So and in this case PA happens to be an integer pointer, so A also should happen to be an integer variable. Okay. So PA is equal to ampersand A, what will happen? So PA, which has a memory location here, will get the address of A, which is 1000. Okay. Now you have PB, which is a pointer variable, a integer pointer variable. So B happens to be an integer. This is a perfectly valid C statement now. So what I get is PB assigned to 1002. So please remember, what is outside, the numbers that you see outside the box are addresses. The numbers what you see inside the box are basically the contents. But when the the boxes associated with the pointers, the number that is stored in the boxes associated with the pointers happens to be address. So 1000 happens to be the address of A, 1002 happens to be the address of B. Now if I say PA plus PB, so PA happens to be the pointer, now it is pointing to A, PB happens to be a pointer, now it contains 1002, a pointer to B. So I cannot do this because PA and PB actually contains 1000 and 1002, but what I want to add is variable A and B. For that I have to dereference that. So star PA plus star PB, what happens? Contents of pointer variable PA, contents of pointer variable PB. So both of them are done, both of them are accessed, and you get and assign it to sum. So I get 30. So please remember, when you use pointers to access the contents of a variable name, so the pointer should first point to that variable name, to the address equivalent to the variable name. Only then you can dereference. Okay. So now if you see, when I say star PA, PA is accessed first. So that means PA, the location here, is accessed first, which contains 1000, and then the 1000 is used to access this location which contains 10. There are two references. Okay. So if there is a way to access A directly, good programmers should go ahead and use it and don't try to use it using pointers. Okay. Because accessing variables using pointers are not efficient. If you see here, there are two memory accesses, access to 1006, which happens to be PA, you get 1000, and then you use that 1000 to get 10. There are two references. That is why we call this as indirect references. Whereas instead of that, sum is equal to A plus B if I had written, because they happen to be in the same function. A is accessible, B is also accessible, sum is equal to A plus B will do exactly the same, but with much lesser memory accesses. In this case, exactly 2 memory accesses lesser than what we have shown here using pointers. Okay. So now the rest of the piece of code, you can print that, put those braces, then put that void main, and then include stdioh. So this is the now a well constructed C program, where there is a clear demonstration of declaring or using integers, declaring integers, assigning integers, and dereferencing the pointers. Okay. Now if I see, I have made some modifications from this, I have taken away all that, I have not assigned it. So now what do I do? So the rest of the code simple. Okay, it remains as it is until this point. So until this point, the code remains the same. So that is the contents of memory at that point of time. So there is a declaration of sum A and B, those are the addresses assigned. So there is a declaration of PA and PB, and PA and PB also have been assigned. So now PA contains 1000, PB contains 1002, just as in the previous program. Now instead of assigning, I read it from interactive keyboard, scanf %d, you remember this ampersand A. So at that point of time, probably the teacher then would have told that this is the syntax to read variables from the keyboard. Okay, so you might have simply followed. So please remember that now A and B now happens to the ampersand A and ampersand B happens to be the pointers to A. You remember scanf is a function, and you know the way we define functions. So functions at this point of time, what has been told to you is it can return only one value, but here this scanf function is returning you two values, the two values that you typed in for A and B from the keyboard. Okay, so please remember this. So scanf has already introduced you pointers, but at that point of time it was not appropriate for the teacher to discuss what is this ampersand A and ampersand B. Now it should be clear to you that using pointers you can probably now write functions which can return multiple values. By default, you know functions in C will return only one value. So, here because you are passing the addresses of A and B to the function scanf, scanf now has, scanf is a separate function. So, scanf has now access to location A and B, which happens to be the local variables of main. That is another power of pointers. Okay. So, by default functions in C returns only one value, but that will not solve all the problems. You need to have a way where a function can return multiple values. So, by sending the pointers to variables instead of the values, if I say A and B, scanf A and B, you will be sending the values of A and B. So, that gets copied onto the scanf function and it cannot return anything. So, now instead of sending A and B, you are sending the address of A and B. So, when the control gets transferred to the scanf function, because you have passed address of A and B, it can manipulate or it can reference the addresses 1000 and 1002 in this case. Okay, the scanf function can access A and B. That is another power of pointers. So, that is what we do, and if I say, if I enter 10 and 20, the scanf will read 10 and 20, it directly modifies the location 1000 and 1002. There is no return actually, it directly modifies. Okay. And then you get, if you put sum is equal to star P A plus P plus star P B, you get the same effect. So, instead of ampersand A and ampersand B in this line, look at this scanf statement, I have removed the ampersands, but the variable name still happens to be the pointers P A and P B. So, earlier it was ampersand A and ampersand B. I have replaced that with P A P B, and if you see in the earlier two statements, I have initialized P A to ampersand A, P B to ampersand B. So, what are P A and P B? They are pointers. P A points to A and P B is pointing to B. This is equivalent to writing ampersand A and ampersand B. So, even this is a valid code. Okay. So, in the last in this particular example, we have seen multiple ways of using pointers and multiple ways of accessing pointers. One key lesson that we have seen, or one key observation that we have made in this example, is through a function which you already know, which is scanf, which use ampersand A ampersand B to get the values that you type from the keyboard. So, ampersand A and ampersand B happens to be the pointers, because now you know ampersand is an operator, which returns the address of the operand. Okay. So, in this example, I have P A P B, which is already capturing the address of A and B. So, instead of doing ampersand A ampersand B, and now I can use P A and P B as well without hurting any of the concepts or any of the programming requirement. Let us quickly see another example. So, I have int A, now very familiar int A, then I have int P1 again, that is also very familiar, then I have a special case here. What is this? I have int star star P2, I have 2 stars. So, what does that mean? Okay. So, if you see it is integer star basically, and what is star P2? Star P2 is a pointer to integer or a pointer. Okay. So, this is pointer to pointer basically, we will see how to use it. Okay. So, internally if I write these 3 statements, this is what I get. So, I get 3 memory locations, I get some memory storage for it. So, this 1000 is associated to A, 1000 to P1, 1004 to P2. Now, if I say A equals 10, now you know familiar what happens. Now, if I say P1 equals ampersand A, you know what happens. Now, if I say P2 is equal to ampersand P1, I get that. Okay. So, till this, except this int star star P2, you know most of the things. So, all these are basically recap of the usage of the things that we have already done. Now you see, if I say print a is equal to percentage a, very familiar, what you get 10. If I say integer star p1 and if I say star p1, what should I get? So if you remember, p1 is a pointer, star basically dereferences the pointer, so p1 contains 1000 and star happens to be the contents of 1000, which is 10. I get 10. Then let us see the last case, which is pointer to pointer. That is what we see here. So if I say printf percentage d and p2 and I put a star and I put a star, okay. So p2 happens to be this, star p2 happens to be the 1002 and this 1002 and this 1000. Star p2 basically will give me 1000, because p2 contains 1002, 1002 contains 1000. So star p2 will give me 1000 and I have another star. So star p2 will now give the contents of 1000, which is 10. Okay. So this also programmers use it for solving many issues, especially when they handle data structures, okay, which are basically data types of very complex composition. So they use these concepts of pointer to pointers, dereferencing the pointers, void pointers, and so on. So this is another example where we have kind of recapped the things that we have learned, and in addition we also demonstrated that a pointer variable is just like any other variable. Okay, so the star p2 is now a pointer to a pointer. A p2 is now a pointer to an integer pointer. So p2 contains 1002, which happens to be the address of a pointer. So 1000 is the p1 is the pointer, 1002 happens to be the address of that pointer. Okay, and we also know how you can, this is double indirect basically, star p2. You access p2, you get this address. You access 1002, you get this address. So two references already, and you go there and access the third reference. So this is double indirection. Basically you have to do 3 accesses to get into 10 using p2. So now to sum up, if I refer a, I get 10, which is called as direct. If I refer p1 using a star p1, it means I access p1 and then 1000, which is one level indirect. If I use p2 by using star p2, I get, first I go to p2, I get 1002, I go to 1002, I get 1000, and I go to 1000, I get 10. So there is double indirection or 3 memory accesses. So the rest of the code can be easily completed. Before we wind up, we will see a couple of slightly complex declaration of pointers, okay, because I have to give you some food for thought before we wind up this hour of discussion. So integer a, we are familiar, a is a, so if I go back, a is a pointer, a is an integer. If I say integer star p, p is a pointer to, so star p is pointer to an integer. That's how you have to decrypt. If somebody gives you a piece of code, to understand what is this p, you have to decrypt it like that. So p is pointer to an integer. If I say integer star p, p is a pointer to a pointer to an integer. So the first is a pointer is the first star, to a pointer to is the second star, and the last one is an integer. So a pointer to an integer. So let us look at another very important say data type, which are arrays. You are already familiar with that. So I declare a of 10. So what does it mean? A is an array of 10 locations of type integers. So a is an array of 10 integers. Now if I say int star p5, so as I said, you can declare an integer, a pointer to any data type. So p is a pointer, p is an array of 5, So, what is star? Is a pointer. So, P is an array of 5 pointers to an integer. So, what do you get? You get basically in the name P, you get an array of 5 locations, and what is contained in those 5 locations? 5 pointers, 5 addresses. You can store 5 addresses when you declare a variable name like this. Okay. So, P is an array of 5 pointers to integers. So, just like A is an array of 10 integers, P is an array of 5 pointers to an integer. Let us look at this. So, look at the previous one, this is star P of 5. So, now I bracket star P. So, can you guess what this happen? So, the first thing that interprets is P, and because there is a bracket, it has to complete the bracket operation. So, now P is a pointer, okay. P is a pointer 2, and now 5, an array of 5 integers. So, P is pointer to an array of 5 integers. These two are very different. Star P of 5 without any brackets is very different from this. So, what did you get in the previous previous shot? You got an array of 5 pointers. So, what do you get here? You get a pointer which is pointing to an array of 5 integers. These are very different. So, the array contains integers here, and P points to that array. In the previous example, the array will be declared to hold 5 pointers. So, these are very important. Anyway, we are going to revisit this when we take arrays together with pointers. You have A int B. A is a function accepting an integer variable as parameter, and that is an integer, returns an integer value. So, what we have seen in this last 1 hour is we have seen what a pointer is, how to declare a pointer. So, what a pointer is a variable name, or pointer is a variable which holds an address, just like integer holds an integer, a floating point holds a floating point, pointer holds an address. But please remember, C is not strongly typed. So, if you put a junk, if you put a number into a pointer variable, it does not complain. But the problem is when you use this pointer to dereference, if you say star P, and when P contains some junk value, you must have all faced this error. In Windows, we get something called as segmentation fault or memory error, okay. Because we are now introducing you to pointers, but C, the compiler C, would use pointers extensively for so many things that you already know. Scanf is one of them. Array is another of them. Arrays, we are going to study it in detail, but within the learning that you have already done with respect to C, you already, either you or the compiler inside would have used pointers to give the logical meaning for many of the statements that you have learnt, okay. So, how to declare a pointer we have seen, how to initialize a pointer we have seen, how to access a data using a pointer we have seen. We have also seen a special case where I have a pointer which holds another pointer, which we call it as a pointer to a pointer. Then we also see how to initialize, and then we know how to declare and initialize together in the same statement. The only condition there is what appears on the right hand side of the assignment should have been earlierly defined, okay. I can say int A, and then I can say int star IP is equal to ampersand A, but I cannot reverse these two statements. Then we also seen how to access data using pointer to a pointer. So, when we said star star X, so there was a 2 level of indirection. So, this is what we have covered today. So, we have seen basically what is an address, what is a pointer, and what basically the two operators ampersand and A, and we have seen the several ways of using pointers. Okay. So, I urge you to look at the references, go through what we have done today, so that the next class we can probably see slightly complex utility of pointers. So, primarily we will see how pointers are used in functions and make functions return more than one value. In fact, there is no return, but the effect is a return. Okay. So, we will see that in our next class. Thank you.